we want to match each of these exponential functions to its corresponding graph. Now, to do this, here's what I'm going to look at. I'm going to look at the growth rate. Remember, when we have an exponential function, like this one here, here's the general form of an exponential function, a naught times b to the kx. Now, in each case here, a naught, that a sub 0, that's the start value. That's the start value. That's how many objects you start with, or the initial value, if you like. So at time 0, the output is going to be, right, at time 0, k times 0 is 0, b to the 0 is 1, 1 times a naught is a naught. So you start with this many, say, bacteria. At time 0, you start with that many bacteria. Then, this coefficient right here, that's the growth rate. Now, it's positive in this case, so we got a growth. That's what we can see over here. All these are growth, right? 4, well, we got a 0.4, a 1, and a 3. All those numbers are positive, so we have these growth functions. Now, the bigger number, the faster it grows. The smaller number, the slower it grows. So to do these problems, I'm going to look over here and make these comparisons. I've got 0.4 and then a 1 and a 3. Well, the 3 is the biggest number, so this is going to be the one that grows most quickly. Now, the one that grows most quickly, it's this one here, right? This one goes up. As we go left to right, this one goes up. No, it's actually this one, right? As we go left to right, this one rises more quickly. So for this one right here, I think that's going to be item C. So I'm going to claim that this is C. And now the smallest growth, that's this one. The 0.4 is smaller than 1. So this is going to be the smaller growth. That means as we look left to right, the curve that increases more slowly. Now compare this one to this one. This curve here increases more slowly, right? This is going up at this rate, whereas this one down here goes up much more quickly. So I think this one here, the top one, is the graph of that function right there. So I'm going to say this is A, and that must mean that this is B.